The Müller-Lyer illusion. Why equal lines look unequal. Before I explain today's topic, I want you to look carefully at these two horizontal lines. Which one appears longer? Well, most people immediately would choose one of the lines. However, the surprising answer is that they are exactly the same length, and the arrows surrounding the lines change how we perceive them, even though they do not change in their physical size. This visual experience is called the Müller-Lyer illusion, and it demonstrates an important psychological idea. What we perceive is not always an exact copy of what our senses receive. And by the end of this lesson, you should be able to explain the Müller-Lyer illusion and apply the idea that visual context, expectations, and experience can influence perception. Sensation and perception are different. To understand this illusion, we first need to distinguish sensation from perception. Sensation is a process through which sensory receptors detect physical stimulation. As you can see in this example, the eyes receive information about two horizontal lines. Perception is the way the brain organizes and interprets that sensory information. Perception allows us to recognize objects, judge distances, and decide what we are seeing. And these processes usually work together so smoothly that we do not even notice the difference. However, visual illusions reveal that sensing something and perceiving it are not always identical. In the Müller-Lyer illusion, the sensory information from the horizontal lines indicates that the lines have the same physical length, and many people perceive one as longer. The illusion therefore shows that the perception involves interpretation rather than simply recording the world exactly as it is. What is the Müller-Lyer illusion? Well, the Müller-Lyer illusion consists of two horizontal lines of identical length. One line has an arrow-like ends pointing outwards, while the other has ends pointing inward. And even though when the lines are placed directly beside each other, one can often appear longer. But the most important point is that the arrows do not physically change either line. They only change the visual context surrounding the lines, and you can prove this using a ruler, as you can see in this example. If both lines are measured from one endpoint to the other, their lengths are equal. And this creates a conflict between measurement and immediate perception. A ruler can tell us that the lines are identical, but our visual experience may continue to make them look different. And knowing that an illusion exists does not always make it disappear. And this is because perception happens quickly and automatically, and the brain begins interpreting visual information before we consciously reason through what we are seeing. So why does this illusion happen? Well, this illusion happens because the brain does not interpret each visual feature in isolation. It uses the surrounding context when deciding what an object looks like. According to the textbook, our perceptions are affected by factors such as beliefs, expectations, experiences, and cultural context. The arrows attached to the lines become part of the information the brain considers, and instead of judging only the horizontal segment, the visual system responds to the entire pattern. One way to understand this is to compare the brain to a detective. A detective does not normally make a decision using only one piece of evidence, but instead the detective combines several clues and reaches the most likely interpretation. And the brain does something similar. It combines the horizontal line, the angles at its ends, and previous visual experience. And usually using context helps us understand the world accurately and quickly. In this particular image, however, those contextual clues lead to an incorrect judgment of length. The illusion is not evidence that the visual system is useless. It demonstrates that the brain normally relies on interpretation, and interpretation can occasionally be mistaken. The outward and inward facing angles can resemble the corners of rooms or buildings. One pattern may resemble an inside corner that appears to move away from us, while the other may resemble an outside corner that projects towards us. And if the brain interprets one line as farther away, it may adjust its judgment of that line's size. In everyday life, an object that creates the same retinal image while appearing farther away would normally have to be physically larger. And therefore, the visual system may interpret one of the equal lines as longer because of an implied difference in depth. And this explanation is useful because it connects the illusion to normal perceptual processes. Our brain regularly interprets two-dimensional retinal images as three-dimensional scenes. However, the cross-cultural evidence suggests that experience also plays an important role, and that illusion should not be described as resulting from one simple mechanism in every person. Research finding and cultural experience. The Müller-Lyer illusion is also important because it has been used to study how culture and experience can influence perception. And the textbook discusses a multinational study published by Marshall Segal, Donald Campbell, and Melville Herskovits in 1963. The researchers found that people from different cultural environments did not respond identically to every visual illusion, and Western participants were more likely to experience the Müller-Lyer illusion than participants from some non-Western cultural settings. One proposed interpretation is that people living in environments containing many rectangular buildings, straight lines, and right-angled corners gain extensive experience interpreting these visual patterns as depth information. This finding does not mean that every Western person experiences the illusion or that people from other cultures never experience it. It just means that the perceptual tendencies can vary and that experience may influence how strongly an illusion is perceived. And this research supports the textbook's larger point in that perception is influenced by more than just sensory input alone. Personal experience, expectations, and cultural surroundings can affect how sensory information is interpreted. Application and conclusion. The two horizontal lines are physically identical. However, because the arrows create different visual contexts, the lines may not appear identical. And this teaches us several important lessons. First, that sensation and perception are related, but different. Sensation provides the visual information, while perception organizes and interprets it. Second, perception is influenced by context, and that the surrounding arrows change how the horizontal lines appear. Third, perception is also shaped by experience, and the cross-cultural research discussed in the textbook suggests that people's environments may affect how strongly they experience particular visual illusions. Finally, visual illusions remind us to think critically, and something may appear obvious while still being physically inaccurate. The main takeaway is that seeing is not a passive recording process, that the brain actively interprets sensory information by using context, expectations, and previous experience. And this usually helps us navigate the world efficiently, but the Müller-Lyer illusion shows that the brain's best interpretation is not always correct.